Hi guys, today I'm going to be going over questions 21 through 25 of the 2018 AMC8. Timestamps to each individual question will be provided in the description. Question 21 states, how many positive three-digit integers have a remainder of 2 when divided by 6, a remainder of 5 when divided by 9, and a remainder of 7 when divided by 11? Okay, so first of all, the first thing you can see here is that all of these remainders are just the factor, or what you're dividing by, minus 4. So 6 minus 4 is 2, 9 minus 4 is 5, and 11 minus 4 is 7. So essentially what you're looking for is a positive three-digit integer that is 4 minus a integer divisible by 6, 9, and 11. So let's find the LCM of 6, 9, and 11. So that would be 2 times 3 squared times 11 for the LCM. So that would be 99, or let's do this first, 18, 198, or 198. So we want to find positive three-digit integers that are always 4 less than a multiple of 198. So let's count those out. The first one would just be 194. The second one, 198 times 2 minus 4 is 342. The third one is 590. The fourth one is 788, and the fifth one is 986. So those are the only 5 positive three-digit integers that satisfy all of these conditions. So that is E. Question 22 states, point E is the midpoint of side CD in square ABCD, and BE meets diagonal AC at F. The area of quadrilateral AFED is 45. What is the area of ABCD? Okay, first of all, let's assign a variable x to denote the area of triangles CEF. Let's call it x. So now we know that the area of ABCD is 2 times 45 plus x, because triangle ACD is half the area of triangle, or the square ABCD. So this equals 90 plus 2x. Now let's think about triangle ABF. Triangle ABF is similar to triangle CEF. So, and it's these sides have a ratio of 2 to 1, with AB being the 2 and CE being the 1. So the areas would be this, or the area ratios would be the square of that. So triangle ABF would have an area of 4x. Now we know that triangle BCE is only 1/4 of the area of the square ABCD, because this is 1/2 of the side, and this is a full side, and then you divide the area by 2. So this would be 1/4 of the total area. So we know that trapezoid ABED, or 45 plus 4x, must constitute 3/4 of the total area, which is 90 plus 2x. So now we can just solve for x. Let's multiply 4 by both sides. That would be 180 plus 16x equals 270 plus 6x. 10x equals 90, so x equals 9. So if x equals 9, then the total area, or the area of ABCD, would be 90 plus 2 times 9. that equals 108. So the answer is B. Question 23 states, from a regular octagon, a triangle is formed by connecting 3 randomly chosen vertices of the octagon. What is the probability that at least one of the sides of the triangle is also a side of the octagon? So there are 2 cases here. Either the triangle looks like, let me just change colors here. Either the triangle looks like this, or the triangle looks something like this, where it only has one side on the octagon, or it has 2 sides on the octagon. So let's think about both cases. Let's say that case number 1 is 2 sides on octagon, and case number 2 is 1 side on octagon. So case number 1. For this, we can just count all the cases. We can just, so this is 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 triangles that can be created with case 1. For case 2, you might need to do a little bit more probability-based stuff, combinatorics-based stuff. So for case 2, what is the probability that only one of these sides would be on the octagon? So then for that, you can choose any of the other 4 points on this octagon to be part of the triangle, and they all create different triangles. So there are 8 possible bases, first of all, and then there are 4 possible points to go to after you choose a base. So 8 times 4 equals 32. So then the total number of cases would be 40, where that works. Now let's think about the denominator, or how many triangles that you can make in total. So that would be 8, or here, let me erase this. That would be choosing any 3 points of these 8 you can choose. So that would be 8 choose 3, which is 56. So 40 over 56 equals 5 over 7, and the answer is D. Question 24 states, in the cube ABCDEFGH with opposite vertices C and E, J and I are the midpoints of edges FB and HD respectively. Let R be the ratio of the area of the cross-section of EJCI to the area of one of the faces of the cube. What is R squared? Okay, first of all, let's assign a variable for the side length of this cube. Let's say it's S. Then this is S over 2. S over 2, S, S, S over 2, S over 2, S. We can see that, and this is a right angle. So we can see that each of these sides are, what is it? S squared plus S over 2 equals EJ squared. So this means root 5 S over 2 equals EJ. And that's true for all of these sides. So this EJCI is a rhombus. You can find the area of the rhombus by multiplying the diagonals and dividing that by 2. So let's see what EC is. So EC is just AC squared plus AE squared. That equals EC squared. So what is AC? AC is S root 2, and this is S. So S squared plus 2S squared equals EC squared. So EC equals S root 3. S root 3. And what is JI? Well, JI is just going to be the same as BD because it's just S over 2 higher than BD. And BD is S root 2. So S root 3 times S root 2 over 2 equals S root 6 over 2. And that's the area of EJCI. One of the faces, S squared. And one of the faces of the cube would be S squared. So the ratio of EJCI to one of the faces equals root 6 over 2. And root 6 over 2 squared is 6 over 4, or 3 over 2. So the answer would be C. Question 25 states, how many perfect cubes lie between 2 to the 8th power plus 1 and 2 to the 18th power plus 1 inclusive? Okay, so first of all, let's compute 2 to the 8th plus 1. That equals, this equals 256, so this equals 257. So the smallest, or the cube right below that would be 6 to the 3rd, which is 216. And the cube right above that would be 7 to the 3rd power, which is 343. So this is where we start from. Now let's think about 2 to the 18th plus 1. 2 to the 18th plus 1 is 2 to the 6th to the 3rd power, which is 64 to the 3rd power. So obviously 64 to the 3rd power plus 1, the perfect cube right below that, would be 64 to the 3rd power. So our range is from 7 to the 3rd power to 64 to the 3rd power, which equals 64 minus 7 plus 1. That equals 57, 58. So that's E. Thank you so much for watching. Stay tuned and subscribe for even more math content in the future.